7.2 number 7, we're working with the addition and subtraction formulas, or the sum and difference formulas. So they want us to evaluate this, but 11 pi over 12 is not on the unit circle, so we're going to take 11 pi over 12 and we're going to break it into two angles that either add to make 11 pi over 2 or subtract to make 11 pi over 2. Now these are not my only options, but I'm choosing these options because they're the first ones that came to my head. I explained how to break this up in class. 9 pi, 2 pi is 11 pi, 12 and 12, same denominator when we add. I chose these two numbers because 9 pi over 12 reduces to 3 pi over 4, and 2 pi over 12 reduces to pi over 6. So now we can go ahead and go to our formula sheet, and we're looking for the sine of two angles that are added together. So the sine of two angles that are added together is the sine of s plus t equals the sine of s cosine of t plus the cosine of s sine of t. Here s is going to be 3/4, or sorry, 3 pi over 4. T is going to be pi over 6. S is going to be 3 pi over 4. And t is going to be pi over 6. We go to the unit circle and we evaluate the sine of 3 pi over 4. That's going to be square root of 2 over 2. So that's what that is equal to when you go to the unit circle. Cosine of pi over 6 is square root of 3 over 2. Cosine of 3 pi over 4 is negative root 2 over 2. Sine of pi over 6 is 1/2. All off the unit circle. We can multiply here, so we get the square root of 6 over 4. We can multiply here, so we get negative root 2 over 4. And when we combine those together, we end up with this. We cannot actually subtract these two because the radicals are different, so that's your final answer. Tangent is the same way, so I'm going to break this up into two angles who add to give me 19 pi over 12 or subtract to give me 19 pi over 12. I'm going to try adding first. 12 and 7, 16 and 3. I think I'll try that. 16 and 3. 16 plus 3 is 19. This reduces. 4 pi over 3 reduces pi over 4. Make sure I did that right. Divide by 4, yes. Divide by 3, yes. So now we need the tangent of an addition. So there it is right there. So I'm going to write the tangent of s plus t and then what it's equal to, which is the tangent of s plus the tangent of t, all divided by 1 minus tangent s, tangent t. And then we're going to replace s with 4 pi over 3 and t with pi over 4. So we have the tangent of 4 pi over 3 plus the tangent of pi over 4, all divided by 1 minus the tangent of 4 pi over 3 times the tangent of pi over 4. Then we're going to evaluate. The tangent of 4 pi over 3 is in quadrant 4. Pi over 3 for tangent is square root 3, and in quadrant 4, tangent is positive. Tangent of pi over 4 is 1. And then we end up with these same things down here. So this becomes the square root of 3 plus 1 over 1 minus the square root of 3. When we rationalize that denominator, we're going to multiply top and bottom by the conjugate. Again, I talked about all that in class. We're going to use either distributive property, FOIL, box method, whatever you would use. So we have root 3 plus root 9 plus 1 plus root 3 all over 1 minus root 3 plus root 3 minus root 9. Up top, square root 9 is 3. 3 plus 1 is 4 plus 2 root 3's, because square root of 3 plus square root of 3 is 2 of those. On the bottom, those cancel. We have 1 minus 3, which is negative 2, and then 4 and 2 are both divisible by negative 2, so you have negative 2 minus the root of 3. Back here, they want me to expand this. This is the secant. We do not have a sum and difference for secant, so we're going to use the sum and difference of the reciprocal of that. So we're going to do 1 over the cosine of pi over 2 minus theta. Now, I'm not going to write the 1 over the whole time, so I'm just going to do the cosine of pi over 2 minus theta. So the cosine of pi over 2 minus theta is the cosine of s, cosine of t, plus sine of s, sine of t. That's what this is. The cosine of s minus t is equal to that from this formula sheet. Now I'm going to replace s with pi over 2, t with theta, and again, I'm not going to write the 1 over here, just for the sake of saving time. The cosine of pi over 2 is 0. The sine of pi over the sine of pi over 2 is 1. So we have 0 times cosine, so that becomes 0. We have 1 times sine, which is sine theta. So my entire denominator, remember this is all under 1, is 1 over the sine of theta, which is the cosecant of theta. The last one, 21, you're given these two pieces of information about these angles. The angles are in quadrant 1. That's what this is saying, from 0 to pi over 2 is quadrant 1, and they want us to find these two things. So first of all, this formula is the sine of A, cosine of B. Again, I'm taking it right off of that formula sheet. I'm just not showing you what it is. I'm just copying it down, replacing the s and t with a and b. So I need the sine of A. When I come up here, I'm given the sine of A, so that whole thing is being replaced with 4/5. Then I need the cosine of B. So I go up here, the cosine of B, that whole thing is being replaced with 1/3, minus. Now I need the cosine of A. I don't have the cosine of A. I have the sine of A, so I have a couple of options. If this was on the unit circle, then I would know what it's paired up with. It's not on the unit circle. So I could use the Pythagorean theorem. I've done that many times in class. This time instead, I'm going to draw a triangle. Here's my angle A. The formula for sine is opposite over hypotenuse. So my opposite leg is 4, my hypotenuse is 5. Solve that using the Pythagorean theorem, a squared plus b squared equals c squared, or you can just recognize that it's a 3, 4, 5. So this leg would be 3. I need the cosine of A, which is the adjacent, which is 3 over 5. We're in quadrant 1, cosine is positive, so this becomes 3 over 5. Times the sine of B. Come up here, I don't know what the sine of B is, I know the cosine of B. Now, again, if this was on the unit circle, I could recognize what pairs up with it. It's not on the unit circle, so what I'm going to do is sine squared B plus cosine squared B, just to show you that there's different ways to do these. You can use these identities, or you can draw a triangle like this. So we have, whoops, that's a plus, 1 over 9 equals 1. Equals 8/9 when I subtract 1/9 for both sides. I get plus or minus the square root of 8 over 3. The square root of 8 is 2 root 2 when you simplify it over 3, and we're in quadrant 1, so this is going to be positive, so this becomes 2 root 2 over 3. Multiply here, and I have 4 over 15, minus multiply here. The numbers outside the radicals can multiply together, so you have 6 root 2 over 15, and then when we subtract, we have 4 minus 6 root 2 over 15. And now we're going to do the same thing, but with this cosine formula. So the cosine formula is the cosine of A, cosine of B. Again, this is coming directly off this formula. Sine of A, sine of B. The cosine of A is 3/5. The cosine of B is 1/3. The sine of A is 4/5, and the sine of B is 2 root 2 over 3. Multiply across 3/15, multiply across 8 root 2 over 15, so we have 3 minus 8 root 2 over 15.